All right, we'll give this a minute for people to join. We'll see. We'll go over the Algebra 2, starting our next lesson. Okay, we're going to get this started here. So what you guys have probably noticed here is that with this new quarter and the assignments, you do have to go everything in order. So you'll have to look at the survey, look at the preview, and check out the notes before moving on. Today's first assignment worth points. You guys will have to submit it before you move on to the next assignment. It's actually a pretty easy one. I've listened to your guys' survey responses, and I've decided to really kind of pump the brakes a little bit on the lessons. I thought I was going pretty slow, but I guess I'm going to even try to go a little slower. My goal is if we can get through the next two sections and then have a project afterwards, be all right. So here we go. What we're going to do today with the ellipses is just look at these two websites that are pretty interactive and discuss how they affect the equation and the shape of the ellipse. So here we go. I'm gonna actually, you know what? I already have that previewed up for you here. So the first one, they want you to go to this website here. So I'm going to open that in a new tab. And we're not going to click anything. We're just going to look at the equation up here. And we're going to move some things around. So the first question is, all right, A is the center of the ellipse. What part of the equation has changed when you moved A around? So if we look up here, it's okay, x minus 1, x, and then y minus 5. And we got those numbers there. So if I take A and move it around, we can't really see. Let's see if I can zoom that out a little bit. Scroll up. Okay, so as I move A around, notice the bottom numbers don't change. The only numbers that are changing are the parts by the x and parts by the y. And if you actually notice, if I just move left and right, I'm trying to move as left as I can and right as I can, only the numbers by the x's change. If I move up and down, only the number by the y changes. So that's your answer here is, as you move A around, the center around the ellipse, the numbers next to the x and the y changes. Okay, next question on here. Okay, we're going to explore. Okay, next we're going to move V1. What part of the change equation? So V1 here, this is called a minor axis. Well, right now it's minor because it's smaller than V2. But if I move V1, it does stretch the ellipse vertically. And the only number changing is the number on the y denominator. The x doesn't change. The center location numbers don't change. Only the y number changes. Okay, so we'll just put that there. All right, the next part, and I think this is the last thing. Okay, nope, not the last one. Next, we're going to move V2 to see what changes. V2 here, a vertex 2. If we move that, okay, only the number underneath the x changes. In fact, you can kind of see here, if we put our center kind of at 6, I'll try my best. There we go. Oh, it's at 6, 6. That's nice. That number underneath is always equal to the distance from the vertex to the center. So we got 6 squared. If I make it a little shorter, if I go to 4, or try to go to 4, okay, that's 2. If I go all the way out to negative 10, that's 16 because that's how the distance from there to there. So this will help you out in later sections too if you want to go back to this website. All right, next question here. Okay, to make a tall skinny ellipse, what would you have to notice about the equation? Well, let's make a tall skinny ellipse. So I'm going to make that short, make that longer. Okay, what do we notice about it? If I look at the equation up here, x minus 6, y minus 6, and we got a 4.8 or 1.48 underneath the x and a 4.6 underneath the y. Okay, we can answer that. Okay, the number under the y is bigger than the number under the x. So the next part here, you guys okay with those? We're just messing around with it, noticing how it changes the equation. So we can go back later and see how this works. All right, next we're going to go to this Desmos website. So I'll open that up. And we're going to look at the ellipse. Now, technically, ellipse is made from the distance of two focus points. And so if we go through here, you can kind of see we have these focus points here, and these are special points and locations. We're not going to focus on too much because the math to get those focus points is a little complicated, and I've kind of muted this section a little bit. We kind of nerfed it to make it easier for you guys, but I still want to make sure you guys know how we can change this. If I look over here on these sliders, I can change a couple things. One, I'm going to just stop this Z because that just rotates back and forth. But I could change D. D is the magnitude of that focus point. So as I increase the slider, I'm going to have to do this over here. I'll show you guys on the screen. Increases the distance, the collective distance between the two. So we'll just leave it there. But most importantly, what we're going to do is like use these sliders. So I'm going to use A here. And A is going to move this slider back and forth. Or you move the red focus point back and forth. B over here moves it up and down, which if we move it up and down, you can see it really doesn't change anything other than the location vertically of the focus point. And then we got this other slider down here, C, which moves the blue point. So we got a couple questions here that we got to answer. So what happens as you increase the distance between the focus points? So what happens to the graph as we change the distance of the focus point? So I'm going to move this slider. As I make this focus point gets longer, what happens to the ellipse? It gets skinnier. If it's closer, there it's a really round ellipse. An ellipse is an oval, basically. So, but as I make the distance further and further and further, it gets skinnier and skinnier and skinnier. There's a second part to this, so make sure you answer two parts. Is there a limit? Yeah, the limit is once the distance gets bigger than the magnitude. And actually, the distance gets too far to make a circle. It gets so skinny that it no longer exists. We probably can get this, I don't know. Yeah, technically, it's a line right there. There we go. Next part here is, there's the question. Last question here. What conditions need to happen to the ellipse to turn it into a perfect circle? This problem, we're not going to look at the magnitude, so we're not going to affect D at all, because we could make a circle, but technically it looks like a circle, but it's technically really, really round. A really round oval. It's never a circle if we make this bigger and bigger and bigger. The only way to be a circle is if the two focus points, so I'm going to move the one over, are lined up in the exact same location. So if you look at that one side, lined them up perfectly, that's the center, and we have one single radius that's the same all the way around. In fact, if I go back to play P, you can see that radius, that line is the same all the way around the circle. Okay. So if you need some help answering those questions, this video does kind of help you out. I pretty much gave you the answers there. So I wanted you guys to explore a little bit with this. Guys, feel free to move along with this section. If you want to just, crank this out in a couple hours, feel free to do that. I've set this up to it. I've really taken away all the difficult sections. We're not going to be completing the square at all in this section here at all. We'll just use Desmos when we get down to it, and we'll work our way around it. So we're going to keep this really simple since we are on a different learning pathway. All right, best of luck. Stay safe. Have a good one.